I am Anil Kumar. Welcome to my series on trigonometry. In this video, we'll look into compound angle formulae for sine, cosine, and tangent. We'll derive double angle and half angle formulae. We'll also take up related examples from the textbook. The whole idea of this chapter is to follow a sequence so that in your mind you can get all the related formulae and you can connect with them so that you can apply when needed to solve questions.
Our approach, engaging minds, help us to perform much better. We can now connect to context, visualize strategy, apply learnings, and bridge the gaps. Engaging minds help in creative thinking and problem solving. Gain the confidence. Get ready for future. We develop both mathematical and social skills. I can be part of your success story, build strong foundation, and ensure bright future. That is the gift of education. You can always contact me on the email address given. Join my classes. Let us now enjoy the class with Arya. Hi Arya, how are you doing?
Hi, Anil sir. How are you? I'm good.
Very good, very good. So tell me, what do you want to learn today?
I think we're gonna do equivalent and compound formulas for trigonometry.
Okay.
So I think that.
So let me go in the reverse order. Normally, people do equivalent fractions first, spend a lot of time there. I say it's a waste of time. So we'll put it on the side. We'll begin with the compound angle formula. That's kind of difficult and new for you, right? So we'll just go
Right.
through that. And we will see how do we derive the equivalent trigonometric ratios with compound angle formulas and how they are related, right? So we'll go back to them later and see, well, that was just a part of it. You get the idea.
Sounds good.
So we'll have a different approach in this particular sense. Let me share with you a whiteboard and then we'll begin with compound angle formula, correct? So do you know anything about compound angle formula?
Nothing. I think it's like putting two like primary trig ratios together.
Okay, so that's very good. So I love that. So you're absolutely fresh, just as my whiteboard, right? There's nothing on it. So
Yeah.
try to grasp what I'm saying, and that should hopefully make some sense, right?
Okay.
Let me begin with the formula, and we'll see how to manipulate these formulas and get more formulas, right? Now, I've seen students mugging up all these formulas and wasting their time. We will see how to remember them without mugging,
Okay.
But after all, you have to remember the formulas, right? So let me give you the very first formula to start with. So it is sine A plus B. When we say compound angle, then it is definitely not one angle. It is more than one angle. And we normally say, well, A plus B, then what it is, right? You know what is sine A in a triangle, right? Opposite side over hypotenuse, correct?
Yeah.
But now if I combine any two angles, sine A plus B, what is that? Derivation is given in your book. We are not getting into those details. But the formula here is sine A plus B is sine A cos B plus cos A sine B. That is the formula which is derived. You may go through the derivation in the book. If you don't understand, we can discuss that later. Is it okay?
Yeah. Yeah.
Now, that is my formula for sine A plus B. Now, tell me, what could be the formula for sine A minus B?
Would it
Can you
just be
get
sine A
yeah,
cos B
yeah,
minus cos A sine B?
perfect. Perfect. You got the very first formula absolutely correct. It makes sense, right?
Yeah.
Sine A plus B is sine A cos B plus cos A sine B, and sine A minus B is sine A cos B minus cos A sine B.
Okay.
But tell me, does it make sense? Because see, how do we derive this? So let me just try to show you how it is making some sense, right?
Yeah.
We'll relate it with the cost rule.
Okay.
Okay. So when I say sine minus b, right? Only difference is sine is become minus b has come into picture, right?
Right.
So earlier we were talking about an angle which was b, right? And
Okay.
now we are talking about an angle which is minus b. That is what it really means. You get the idea?
So instead of going counterclockwise, you're going clockwise.
Yes. So
Okay.
basically what has happened is that sine of minus b is equal to minus sine b. Do you understand? Because you are in quadrant 4.
Yeah.
That's me. Sine is basically odd function, right? So minus b is not the same thing. It is minus of sine b. You get the idea?
Right.
It's an odd
Yeah.
function. However, if I use cos minus b, in that case, because cos is positive in quadrant 4, it has to be cos b. You see that?
Right.
So now look at it. Look at it. The only change is that the b has become minus. So if I go back to the first formula and substitute minus b instead of b, what happens? I get sine of a and I have substituted minus b, right? So I'm
Right.
writing instead of b minus b. Now what really happens is a has not changed, but b has changed to minus b, right? Plus
Right.
a has not changed, but b has changed to minus b. How?
Uh,
We know that cos is the even function, and therefore cos of minus b is same as cos b. So the
right.
first term remains as such, sine a cos b, and here sine minus b becomes negative sine b, and therefore this
Quadrant
sign
4.
changes to, does it
Uh,
make sense to you?
yeah, because the cosine, when you do minus b, you're going clockwise, but then you get into the fourth quadrant. So cos is positive, but if you do sine of minus b, which is what they're saying here, then it would be negative.
Correct.
So, because it's in the it's in the fourth quadrant. So
Yeah,
then
got it.
it's sine A cos B minus cos A sine B.
Perfect, perfect. So while writing this formula, I prefer to write sine a plus b minus will be minus. Does it make sense? Now we
Yeah,
have
that makes
one
sense.
formula, correct? Okay,
Yeah.
now let's look into the second formula, which is cos a plus b is equal to cos a cos b. Slightly different, okay?
Okay.
And minus sine a sine. So in
Okay.
that case, what should be cos of a minus b?
It would be cos A.
Cos A cos B is not going to change because minus will bring us
Because
to
the minus would still be quadrant 4, but the
Yeah.
sign would change. But the sign would be no, it'd still be negative.
Because A is still positive, right? So only B has gone to the negative part, quadrant 4.
Yeah, so
So
it'd be
only
positive.
one negative will make it positive.
Right.
So cos A minus B is cos A cos B plus sin A sin B. Does it make sense? These are your
So
4 formulas
cos-
given.
So cos A plus B is equal to cos A cos B minus sine A sine B, but cos A minus B is cos A cos B plus sine A sine B, so it's just inverse.
Correct. Do you get the idea?
Yeah, I
Because the
get.
concept is that we know that sine of minus b is basically minus sine b, right?
Right.
But cos of minus b remains as positive, right?
Because it's the
Cos
fourth.
is even function. This is odd function, right?
Right. Right.
Basic definition.
Based on
Is
the
it clear?
castle. Yeah, I got the idea. Yeah, that makes sense.
Idea, right? So, okay, let's move forward. This is first set of very important formula.
Okay.
We'll keep coming back to this so that we really understand what it is all about, right? Let me get to second set of formula. So which is even interesting. The sine A plus B is basically equals to, tell me what?
Sine A cos B plus cos A sine B.
Okay, sine A minus B is what?
Is sine A cos B minus cos A sine B.
Very good. Now let us say if I add them up, what do I get?
2 sine A 2 cos B minus 2 cos A, 2
So
sin.
these terms cancel, right?
Oh yeah. So it's 2 sin A cos B.
2 sine A cos B. I forgot to write A in between, but we can insert. Does it make sense to you? Right?
Yeah, that makes
2
sense.
sine A cos B, right? 2 sine A cos B. Very good, very good. So we got this formula, right? So this is another formula. Right? Similarly, this is another very important formula. We'll come back to this soon. Sine, I wanted to write A. Let me redo it because I wrote C. I don't know. Cos came very close, right? So sine 2 sine A cos B. Is that okay?
Yeah.
2 sine A cos B, right? So this is another formula which is sine A plus B plus sine A minus B is 2 sine A cos B.
Right.
Great. Now, okay. So similarly, we could say cos A plus B plus cos A minus B will be what? Can you tell me from your memory?
Well,
The
cos
second
A.
terms cancel, right?
Yeah, so it's 2 cos A cos B.
Very good. Very good. Very good. So now what is cos A plus B minus cos of A minus B? Tell me that.
It would be 2 cos A cos B.
Minus means the first terms will
Plus.
cancel, that is cos A cos B will cancel, and that minus thing will remain, right? So what will you get?
2 oh yeah, why sine A? How do we get sine A sine B?
So let me write down the formula once again for you. So what is cos A plus B equals to?
Cos A cos B minus sine A sine B.
And if I write this as negative,
Then you plus.
so if I add them up, subtract them up, we are subtracting, right?
Right.
So that minus minus, these things will cancel, this plus will become minus, so you get minus 2 sine A sine B.
Oh, okay, I see.
You get the
Yeah.
idea?
Yeah.
However, if I do this minus here, this is very important. It is minus 2 sine A sine B. Many times we make this mistake. Here, if I do sine A plus B minus sine A minus B, what do I get? So when I subtract, these terms will cancel, right? But
Right.
this will add on to cos A sine B. Do you get the idea?
Yeah, I get that. That makes sense.
So we could even add the sum and we could subtract those things. We could do all these manipulations. So we are getting into like huge things now, right?
Right.
All this will soon make a lot of meaning for you. Let me just share with you now one more set of formulas. I have actually given you at least 8 formulas so far, and which I hope you remember without remembering, right?
Okay.
So sine A cos B plus cos A sine B, right?
Right.
Now, if I substitute A equals to B, then let us say, yeah, A equals to B equals to, let's say, theta. I'm
Okay.
making both of them theta. Then what happens? See this. Sine of theta plus theta equals to
Sine theta cos theta plus cos theta sine theta.
so what is this?
Sine 2 theta equals to 2 sine theta plus 2 cos theta.
Double angle formula. Sine 2 theta, we got double angle formula is equals to 2 sine theta cos theta. You get the idea?
Oh, yeah, I see.
Double angle. Similar. Now look at this
But
double
the
angle.
angle has to be the same, right, for this to happen?
Yeah,
Or
when the two angles are equal. When A
Okay.
and B both are equal, then that becomes a double angle, right?
yeah,
Right. So if you have a triangle in which like this angle and that angle both are same, right?
right.
Then you can use this formula. This is like all this, right? Why these angles are helping us? Let's look into that. It's the diversion. You know the special triangles, right?
Right. It's
So the
pi
special,
over 4, pi over 490, 2 root 2.
so where should I put 2, right?
So our 2 is on the base, and then our root 2 is there. But then you wrote root 3 here. It should be 2.
No.
2 root 2.
Yeah. The other is 30, 60, 90, right?
Yeah. And then that's 1, 2, root 3. Root 3 is at the height, 2 is at the hypotenuse, and 1 is at the base.
So what you know from here is basically, pi by 3, pi by 6, and all those things, right?
Okay.
But imagine, we could actually work with these combinations, right? We can work with combination of this and this using a plus b, and we can know exact values of more angles. You get the idea now.
Okay.
Let's translate this into degrees. It'll be easy for you to add them up because, we are more conversant with degrees.
45, and then
Right.
that one's 30 and 60 and 90.
Correct. So 30 plus 45 is 75, right? So
Right.
if I have to find what is sine of 75 degrees, what will you do? You have the formula of sine of 30 plus 45, and you know it is in terms of sine 30 cos 45 plus cos 30 sine 45. You know all the exact values. You can add them up and get the value of sine of 75. You get the idea.
So is this to prove it, or is
So
this
find
to
the value, calculate the value, find the value. If you do sine of 45 minus 30, you can find the angle sine 15 degrees. What is the exact value for sine of 15 degrees, correct?
Right.
This is basically sine of 15 degrees, right? And that is sine of 75 degrees. Is that okay now? You know exact values. Not
Right.
only that, I showed you the half angle, double angle formula, right? Twice the angle, correct?
Right.
So twice the angle. If I tell you what, find the value of sine 7.5 degrees, well, 15 is twice 7.5. So I can use that equation and find sine 7.5 degrees. You get the idea.
Kind of. I'm still a little confused.
But with these combinations of just three angles, you know the exact values, we can actually get exact values for many, many, many more angles, right? Just by adding, subtracting these angles. Do you see
So
the
do they-
power?
So is it only using special triangles that you can do this, or like any triangle?
Any triangle, but special triangle gives you the exact value. The whole thing is doing without calculating.
Right.
You see the power,
Yeah.
right? So we are getting into a portion of trigonometry where you could actually solve problems without calculator very precisely
Right.
with the combination of these angles. Now, let's go back.
Okay.
We'll say cos A plus B is what?
Okay. So it's cos A cos B minus sine A sine B.
Let me put A equals to B equals to theta. Then what do I get?
So you have cos theta plus theta is cos theta, and then another cos theta minus sine theta sine theta. And so then you have cos 2 theta, which is 2 cos theta minus 2 sine theta.
Squared, squared.
Oh, yeah, squared.
Cos theta times cos theta is cos
Yeah.
square theta, sine theta times sine theta is sine square theta. So
Yes.
that gives me a double angle formula of cos 2 theta, which is cos square theta minus sine square theta. Is that correct?
Okay.
Got it, right?
Yeah.
Now, you also know that I could write cos square theta as 1 minus sine square theta, right?
Yeah.
You know, right? Because that Pythagorean theorem, Pythagorean ratio, cos square theta plus sine square theta is what? 1, correct? So that
it?
means cos square theta is 1 minus sine square theta, right?
Wait, why is it equal to 1?
Sine square theta plus cos square theta, why it is 1, you don't know.
No.
Okay. Yes, we'll do it again. Let's do it. Such a easy thing. You'll love it. Let's try to understand. Let's say this is the angle theta, right?
Right.
Let me show you with another example. Let's talk about coordinate axis. And let's say this is the point P. So whose
Okay.
coordinates are x and y. Is that okay?
Yeah.
That really means that this distance, if this is the origin, is x and that is y. And this is r. Is it okay?
Okay.
And we know r square is x square plus y square. And that is how it is, correct?
Correct.
What is cos theta equals to? X over r. What is sine theta equals to?
Y over
Y.
R.
Okay. Now, from here, we'll derive all those Pythagorean trigonometric ratios. We'll just understand how we get them. We know what is x square plus y square equals to r square, right? Pythagorean.
Right.
What happens if I divide each and every term by r square? Let's do that.
Then you have x squared plus y over r squared equals to
X
1.
over r is what?
Oh, so that's why sine squared theta plus cos squared theta is equal to 1. I see.
How simple it is, right?
Yeah.
Let's have more fun with it. Okay. Now this time we'll not divide by r square, we'll divide by something else. Could it be x square or y square? Let's say what happens then. You could do that also, right?
Right.
Why not? Why not? Who's stopping you? Just divide. So this is 1 plus, what is y over x?
Tan theta. So tan squared theta
R
equals
over x.
r over x is your adjacent. So,
Secant square theta.
oh, because it's your hypotenuse over your adjacent, which is just the
Reciprocal of cos.
reciprocal of cos. Oh,
What will happen if I divide by y instead of x square, y
you
square?
just get your cosecant. So
Oh
one
my God. Yes, you got it. So we
and
get cot
theta,
square theta
yeah,
plus 1 equals to, sorry, cosecant, right? You
cosecant theta.
see how easy it is? Do you have to remember? You see how we derived them all, correct?
Yeah. So
Easy, right?
these are your reciprocal compound
Yeah,
functions.
yeah. So
Okay.
you have to use them when you do trigonometric identities in the next unit. Is it okay?
Right.
There is no harm learning them now. Perfect, correct? Okay, so let me clear this. Let's get back to cos, right? Cos, we wrote this. Let me continue from here, right? A plus B we wrote like this, correct?
Yeah. Minus sine theta again.
So this basically is cos 2 theta equals to
Cos
cos square
squared
theta
theta
minus.
minus sine squared theta.
Very good, very good. Now, there are actually 3 formulae with this cos because I could write cos as sine and sine as cos. So let me do formula number 1 is this. Formula number 2 is what? Cos 2 theta equals to. I am splitting cos square theta as 1 minus sine square theta. Is it okay?
Okay.
And there is already sine square theta here. What do I get? 1 minus 2 sine square theta. Is that okay?
Why did you change the cos theta into 1 minus sine squared theta?
Because I wanted a different variation to the same equation. So cos 2 theta is also equal to 1 minus 2 sine square theta. Do you see that?
Okay.
Let me do one more variation. Different thing. This is fun. So I'm not changing cos square theta. I'm writing this as such. But what is sine square theta? 1 minus cos square theta, right?
Oh, yeah.
So I could open the bracket.
So cos minus 1 plus cos squared theta is just 2 cos squared theta minus 1. Oh, okay, I see how you got this because when we did the formula, we know that sine squared theta minus cos squared theta is equal to 1. So you just substituted them in for the values that it's given.
Correct.
When you isolate. So you're just making the equivalency of the equations.
Do you see we got 3 different formulas for cos 2 theta, right?
Yeah.
Do you remember what we get for sine 2 theta last time?
2 sine, no, I don't remember.
The first 2 terms, sine theta, cos theta, right? So 2
Right.
sine theta, cos theta. Is that okay?
Yeah.
Perfect. So have a good look at this page. We'll move on and work more with cos 2 theta.
Okay.
So now let me review with you double angle.
What are double? Oh, is that what we just did with our double angle theorems?
Formula.
Okay.
So very interesting, we found that sine 2 theta is basically equals to 2 sine theta cos theta.
Right.
However, with cos 2 theta, we had 3 formulas. One is
cos
squared
squared
theta
theta minus sine squared theta. And then we also had the one where you substituted, so it was 1 minus sine squared theta,
2.
2 sine squared theta. And then there's the other one with 2 cos squared theta minus 1.
So these are your double angle formula. Perfect.
Yeah.
Now, you're asking me why we did all the three formulae and what is the use of all this? I'll show you use of all this in a sec. Oh, we can get tan 2 theta also, no?
Yeah, we did.
Tan 2 theta will be sine 2 theta over cos 2 theta, right?
Yeah.
So the ratio of these two, correct?
Okay.
So we could actually derive a formula of tan 2 theta also from here, right?
Right. I don't think we went over that one.
Yeah, we did not, we'll not go. We'll not go
Okay.
now. First we'll work with sine and cosine, then we'll come back to tan in a different way. Okay. So we'll make it simpler. We'll not make it that difficult. But you could get from here, right?
Right.
Is this clear to you?
Yeah. There are a lot of them.
This is actually the third chapter of compound angle. You will not believe, when you open that compound angle chapter, these are like different chapters. We have already done 2.
Oh, okay.
Yeah.
Yeah. I
But
think tonight I'm gonna,
when you start doing questions from the book, you will realize what have we done in this
I
20
think
minutes.
tonight I'm just gonna try to write down all the formulas from my memory just to see like
You
what
see
I.
how it is going, correct?
Yeah, I see how like the pattern's going. It's a
Pattern,
very
it is. I don't remember any formula. To be very frank with you, I don't
Yeah.
remember any formula. But you will also remember all without remembering. That's the beauty.
Okay.
Let's go back to cos 2 theta, right?
Okay.
Why I keep going back and forth? Because then, yeah, we're trying to
Remembering,
put them
right.
in the memory and get into the habit of recall, put back, recall, put back. You get the angle? So
Cos
there
2
is a constant communication between our thinking and our hand when it's moving. It just comes when you want it. So
It's
cos 2 theta was
cos squared. I thought it was
theta
cos
minus
squared
1.
theta.
Yeah, we'll use these two now. The
Oh,
beauty
okay.
of this formula, we'll just see. I've written here half angle, right? Oh,
Right.
half angle I wrote. That means if I want half the angle, let me do a
Divide by-
substitution. Let's say 2 theta equals to A. Then theta equals to A by 2, correct?
Right.
Let me replace. So we get cos of 2 theta is A. So cos A is equals to 2 cos square A by 2 minus,
Right.
right?
Right. Yeah.
So let me rearrange. So we could write this as 2 cos square A by 2 equals to, I'm bringing this 1 actually here. So it
Oh, so
becomes
it's cos A plus 1.
1 plus cos A, right? Yeah,
Yeah.
1. So cos square A by 2 will be half of this, right?
Right. Oh.
So
then
what is
it's
the
just,
formula of cos A by 2?
oh, so it's cos squared A is equal to 1 plus cos A over 2.
Half. Yes.
Oh,
Square.
so you just took the square root instead of just dividing everything.
Yeah, so cos square A by 2 is this. So cos A by 2 will be square root of that. And of course, when you do square root, it is positive and negative. Right?
Negative. You have 2 values.
And it depends on where the angle is. You know when to take positive, when to take negative. You
So
know
the positive would either be like in like A or C, and then the other negatives would be in S or T, right?
half of that angle if lies on that, right? If I say, what is
Uh,
cos of 200?
So
A
the
by 2.
it'd be
A by 2 we have to find. A by 2 is 100 and
100.
100 is going to lie here. So it is going to be negative.
Right. Okay.
You get the idea. So that
Yeah.
is how, but you see the beauty of this. We have derived double angle formula and then half angle formula for cosine, right?
Right.
Using cos 2 theta formula, do you see how we derived it, correct?
I see. Yeah. You just substituted 2 theta for A, and then theta, you isolated for theta and you got a over 2, and then you just substituted everything in to find the formula.
Yes.
That's how you
So
derived it.
can you find the half angle formula for sine now?
Yeah, I can do it.
How will you do? Tell me.
So we know sine, are we still using cos 2 theta?
Yes, yes, yes.
Okay, so it's 1 minus
See,
sine
remember why? Sine 2 theta has both the terms, sine and cosine. So it's very difficult to isolate. Now
Oh,
this has only one term, right? Cos 2
yeah,
theta
cos 2
is
theta equals
basically is 1 minus 2
sine squared
square
theta.
theta. So I'm
Right.
writing this as cos of
Cos
A equals to 1
1
minus
minus
2
2
sine
sine
squared A
over
by
a over
2,
2.
where the
Yeah,
substitution is that 2 theta equals to A and
and
theta
theta equals
equals to A by.
a over 2. Yeah,
Perfect. So 2 sine square A by 2 will be 1 minus cos A, correct?
right,
So sine square A by 2 will be half of this,
right.
and sine A by 2
2
will
is
be
square root of 1
plus
plus or
and
minus square root.
minus 1.
1 minus cos A over 2.
You get the idea. So easy.
Right.
Good job. So you now know cos
Is
2
that all of them?
theta, cos 2 theta is, don't worry, cos square theta minus sine square theta.
Right.
Well, today you will land up with 30 formulas without remembering, you will remember them all. That's the beauty.
Oh, no. I don't remember some of them right now, though.
Don't worry, don't worry. You will remember by the end of the class.
Okay.
Yeah, even I don't remember. I told you.
I know, sir. How are you expecting me to remember if you know?
I don't remember. So cos
That's not a lie. You're writing them right now. You know that.
equals to 1 minus 2. It's just a
Sine
pattern. Do you see that
square
pattern,
theta,
right?
yeah.
So
Yeah.
we got cos theta by 2 as equals to, I remember it was plus and
Plus or
minus.
minus square root
It is like
of
plus,
1
right?
plus cos theta over 2. And then sine theta over 2 equals to plus or minus 1 minus cos theta over 2. It's just the opposite.
Just so what is tan theta by 2?
It's plus or
Sine
minus,
over cos, right?
right? So it's 1 minus cos theta over 1 plus cos theta all over 2. Or 2 cancels out, so it's just
2
that.
cancels out.
I
So we
see.
got all the double angle formula and all the half angle. You get the idea.
Okay.
Correct?
And then we also have our regular formulas.
Also the regular formula. And we have one more extra formula we have, sine 2 theta. It is required, right? 2 sine theta cos theta.
Right.
Another form. You know those double angles. So do you see all these formulas now? Correct?
Right.
Good. I think you're ready to do compound angle exercise, all the chapters from the book. Do you
Okay.
realize that? So open up that book, whatever your teacher has given compound angle. Let's do them now.
Okay, let's do them.
Yeah. So let me stop sharing. You share.
Okay.
No,
This
leave
is,
this chapter. This is very easy. So I'm not doing that.
yeah,
That
so this
will-
is 3.7. So I think we have to start from, this is
3.8.
3.8.
That chapter, you will realize that you have already done. So I'm not doing that. Is that okay?
Okay. Yeah.
So rewrite each of the expression as a single first oops. Can you tell me the answer of the first question?
Rewrite each expression as a single trigonometric ratio. So sine A cos 2A plus cos A sine 2A.
Yeah.
So you just have sine.
So
Sine-
A plus 2A, right?
Sine, yeah, so sine.
A plus 2A.
Yeah, so it's just
So
sine 3A plus
Sine 3A, correct? Second
Yeah.
one, B tell
plus
me.
cos 3A.
Yeah. Cos 4 and 3 minus sign, so add them up, right?
Right.
Cos of 7x. Do you see that?
Oh, okay, I see what they did. Oh, so you just did sine A plus
A plus
sine
2A.
2A,
Yeah, sine A plus
and
2A.
cos 2A plus cos A. So wouldn't
Yeah,
the first
cos 4A
one
plus
be
3 is.
So wouldn't the first one be sine 3a plus
No, no.
cos 4a cos
So
2
sine,
3a?
this is sine of a plus 2a, right? Sine a cos
Right.
2a plus cos a sine a, so which is sine 3a, correct? The
But then,
second one is cos formula, right?
right.
Cos of 4x plus 3x. When you expand, what do you get? You get
Oh, they're using
4x
our laws. I
cos
see.
3x minus sine 4x sine
4x.
3x. Correct?
That's right.
So you get the answer, right? Cos 7x. You get the idea?
Right.
Easy, right?
Is it right? But where did the sine 4x and 3x go?
Where is sine 4x? You're doing A, right?
No, if we're doing B.
B. So B is cos A cos B minus sine A sine B, which is
Okay.
cos A plus B. A is 4x, B is 3x.
I see. Okay.
Get the idea?
Kind of. I'm a little confused.
Okay. So reduce the screen a bit so that I could write the formula on the side and then we'll correlate. Is it okay?
Okay.
A bit. So that, because the formula is lengthy. Okay, let me write here.
There we
Oh,
go.
very good. That's beautiful. That's beautiful. So because you just learned them today. So what is sine A plus B equals to? Tell me.
It's sine A cos A
Cos
plus
B.
cos B plus sine B cos A.
Cos A sine.
Okay.
Right. Similarly, we have cos A plus B as equals to cos A cos B.
Minus sine A sine B.
Correct. And if I change this plus to minus, we use very different. Then this becomes minus. If I do
Minus,
this,
and that one becomes plus.
so
Right.
have a good look at these formulas. Now you have sine A cos B. So sine cos changes, sine A cos B, right? Sine
Right.
2A, sine A cos B. So sine A cos B means immediately it should get into your mind this sum of angles for sine. So this plus is sum of angles for sine A cos B. So when you add A and 2A, what do you get? 3A, right?
Right.
So it is sine 3.
Oh, I see. Okay, because I didn't realize because the format was given as sine A cos 2A plus cos A sine 2A, which is just the same thing as this. So you have to like correlate the compound formulas to like solve it or simplify
Next
it.
one is expansion of cos A plus B, right?
Oh yeah, because it's cos 4x cos 3x minus sine 4x sine 3x.
Minus, you get the idea?
And because it's minus, it'd be A plus B.
Right.
So it's 4x plus 3x, which is cos 7x.
Yes, correct. I will give you tan formula also here, which we did not take. But anyway, here's your tan formula, right? Tan A plus B. Over 1 minus tan A tan.
Okay.
If this
Oh,
is
so
negative,
this is what they
because
do it.
tan is also negative,
This would be
odd
positive.
function. Yeah. Tan is also an odd function like sine. So
Right.
the sign changes. Do you see? So if I
Right.
have tan of 170 minus 110, then I know it is tan A minus B. You get the idea. It is right.
170 minus 110, so that's just tan of 60.
Tan 60, and you know the exact value, you can write down that value and find. That's why they are saying rewrite each expression as a single trigonometric ratio, then evaluate the ratio. So you do this as tan of 170 minus 110, which is of course degrees, right? 60 degrees. And then you know your triangle, 60
It's
degrees, if you're looking
30,
from here,
60,
is
90.
square root of 3, right?
Right.
That is all you have to do. Don't you think it's simple, right? You're getting it out?
Yeah, it's pretty simple so far.
Next one, cos
Okay.
A, cos B. So don't get into that angle. Just see that angle are same, right? Cos A,
Right.
cos B plus sin A, sin B.
I think that's
Cos A minus B, right?
A minus B, yeah, cos A minus B. So it's
So
5
just
pi
do
minus
5p by 12 minus pi by,
pi over 12. So it's just 4 pi over 12.
which is pi by 3, right?
Right, pi by 3.
And
And then,
you-
you can just do that as it's a 30, 60, 90 triangle.
Yeah. That is why pi by 3 is this. So half, right?
Right. Yeah.
Done, right? It's not very difficult. The thing is, we have to
No, yeah.
correlate the angles which we have just done,
Right. Because
and
it's just
one by. Hmm,
it's the formulas. So
yeah,
like because I need to just remember the formulas. So like by
yeah,
going
yeah,
like
yeah,
one by one. And
correct.
so I think tonight I'm just gonna keep writing the formulas down just to like
No, just like
figure them
75.
out.
How do you get 75? Now, when they say express each angle as a compound angle using a pair of angles from special triangles, that means 30, 60, 45 is your choice.
Right.
90 also, 0 also. 75 is what? 45 plus 30.
30, yeah.
So you get the angle. Similarly, for all these angles, you could do that combination. You get the idea?
Right.
Plus or minus, both will work, correct?
Right.
So when they write 5 pi by 6, how will you do 5 pi by 6?
I think we just did that one, but I think it's cos of pi. I think it have to be 90. It's your pi
You
by
can-
6. It's
Six,
your you
six,
can do like pi by 6.
6 minus 1, right?
Yeah. So 6 pi over 6 minus pi.
That means pi minus this, right? You could do that,
Right.
correct? And get the answer, correct?
Right.
So you could do all those combinations. 105, how will you do? 105, how will you do 105?
105, I would do 90 plus, no, that's 90 plus 60 is 150.
So 45 will be required and 60 will be required.
45 and
40, 60
60.
is 100 and then 5.
Right. Yeah.
So you have to think like this, 40, 60 and then 5, right? So
Right.
that is how you're going to get all these angles. So you can do all that. Is that clear to you?
Right. What about the negative ones?
The negative is the negative side. So you pi by 6, right? So we want negative pi by 6, right? So if you
Right.
want negative pi by 6, then you have to do like 3 minus 4 instead of 4 minus 3. 3 pi minus 4 pi will give you negative. Is it okay?
Right. But those aren't special triangles. Oh, they are special
They are
triangles.
special triangles.
Pi by 2 minus
3 by 6 is pi by 2 minus 4 by 6 is 2 pi by 3, right?
Right.
Okay. Now, they are actually special triangles because 2 pi by 3, if you work out on any acute angle, then 2 pi by 3 is actually pi minus pi by. So this is 2 pi by 3, right?
Right.
Which is related acute angle of pi by 3.
Pi by 3.
So 2 pi by 3 is actually same as pi by 3 when it gets to the angles when you
Right.
but it is a
Okay.
special triangle.
So we
special.
can just do the same thing as like our cast rule where we just use the related
Yes.
acute values
Yes,
and then
yes,
go from there. Okay.
Yeah.
That's what I was confused on because I was like, you used 4 pi over 6. So that's what I thought you can't use. You have to use the exact values, but that makes
Correct.
sense.
Makes sense, right?
Yeah.
So in today's lesson, actually, go to the next exercise.
It's we did number 3,
Now,
yeah?
you can do the rest at home.
I can do the rest.
Yeah, do the
Number
rest.
4, yeah. This
Continue,
is
continue.
use the appropriate compound. Yeah, I can do that.
Wait.
Yep.
Go question 6.
Question 6? Okay.
That is actually previous chapter's question, which we'll do just now.
Okay.
Read the question 6. Where is it? Oh, yeah.
Use the appropriate compound angle formula to create an equivalent expression.
Sine pi by 6. Now, we'll talk about equivalent trigonometric ratios. Sine pi plus x is what? Basically, if you're looking at this is your x, then this is your pi plus x, correct?
Yeah.
So what is sine pi plus x equals to? You are in quadrant 3. So it is
3.
negative, right? Of
Yeah.
sine x. Correct?
Oh, so it's just sine pi plus x equals to minus sine pi plus x?
But using compound angle, we need to show it. So the question here is, use appropriate compound angle formula. So compound angle formula was sine pi a plus b is what?
Sine a plus b is sine a cos b plus cos a sine b. Oh, so that's all you have to do. You just put the negative in front.
So what is cos pi and what is sine pi?
Uh, cos pi and sine pi.
This is your sine curve,
Right?
right?
Yeah.
This is your sine curve and that is your cosine curve, right? I mean, it goes like this, right? So
Right,
as
yeah.
far as pi is concerned, we know at 0, pi and 2 pi, sine is 0, right? So this is 0, correct?
Right.
And cos pi is how much? Cos pi is -1, right?
Right. Yeah.
So negative sine x. You get your formula, right?
Oh.
So using this compound angle, we get equivalent. This is your equivalent ratio, correct?
Yeah. Correct.
So you can do all of that
Right. Yeah.
using the formula, correct? So simple as that. How do you remember the values of pi, pi by 2, 3 pi by 2? Let me tell you that also very critical, very important, very easy. We take unit circle, right? So that means we take a point here, unit away. What are the coordinates of these points?
There's your 180,
1, 0,
1, 0, and then you
0,
can do your
1,
1, and then you can do your
minus 1, 0,
-1, 0, and then you can do your 0, 1.
minus 1, correct?
-1.
Normally, when you have any point here on the curve P, then we write this as x, y, and this as r. What is x value for unit? R equals to 1. X
Right.
value is cos theta, right?
Right.
This is cos theta, and this is sine theta, correct?
Right.
For a unit circle. So x value is cos theta. So for 0, cos theta is 1, sine theta is 0. For 90 degrees, cos theta is 0, sine theta is 1. For 180 degrees, cos theta is -1, sine is 0, right? You see cos and sine values for
I
different,
see.
very,
Yeah.
you see that. So
Yeah,
you
I
can,
see that.
very.
Yeah.
So when you have to put the value of sine pi, cos pi, think about a point on that side, and you know it is -1, right? On the x
Right.
axis.
So that's why sine pi is 0 and cos pi is -1.
-1. You know the point, correct? So using this point, it is very easy to just get the value. You get the idea.
I had a question.
Yes,
So
yes.
for sine pi plus x,
Yes.
we left sine, we know sine pi was 0,
No.
and we know, oh, is it because you
0
multiplied
times anything is 0.
0, right? Yeah. So then it's because our
0
cos
times
pi is
anything is 0, so
-1.
it doesn't matter. What is x?
Oh,
X
so it's
could be
negative
anything.
sine x. Right. That's how you derive it. Okay, I see. That makes sense. Do you have to leave the 0, or can you just write negative
No,
sine
no,
x?
no. I just showed 0. You know,
Okay.
you write 0 minus sine, sine x minus sine x. Okay. Okay,
That makes
great. Let's go to question number 8, right?
right.
Okay, move on. Okay, so let's work with radian. Cos
Okay.
11 pi by 12.
So you can do 12 pi over 12, and then you can do
Now, I will
24.
teach you one thing here. Some teachers don't like that, but
Okay.
I don't mind. So what I do is our learnings of related acute angle will combine those learnings with the compound angle formula. Is that okay?
Okay.
If you don't do that, you might make some questions very difficult unnecessarily. It's not required. So how does that help? So my strategy is very simple. 11 pi by 12 means the related acute angle is pi by 12, correct?
Oh, yeah.
11 pi by 12 is this, and my related acute angle is pi by 12, correct?
Right.
And I know using the cost rule that cosine has to be negative, correct?
Right.
And therefore, I can write this as negative of cos pi by 12 first,
Right.
correct? Because this is same as negative of cos pi by 12.
I
Is that clear
see.
to you?
Yeah.
So what I have done, for any angle, I can write related acute angle.
Right. Okay, yeah, that's what we did for the cast rule, and then you can just put it into your calculator and find the value. Right?
Here we
Because
will
it's
find,
not a special triangle.
here we will find, yeah. Now we have to only figure out what is pi by 12. What is combination, which can be done within pi by 2 range. You understand?
Yeah.
You get my point?
Yeah, so you can do
When it is like
pi.
big number, right? 11 pi by 12, I say, oh my God, I should add what? I mean, 2 pi minus so many combinations, right?
Right,
We
yeah.
don't want to do that. We want to simply, now I have pi by 12. I know pi by 12 is 4 minus 3 is 1, right? So I'll write this as cos of, I'm just writing this step because, it's first time you're doing. So,
Right.
so pi is written as 4 minus 3. Is it okay now?
Upon 12, yeah.
Which definitely automatically, which you are going to get soon,
Oh,
4 by
pi by
12 is
3
pi by
minus
3,
pi
right?
by 4.
Minus this is pi by 4, correct?
And then you can use your compound angle
Now you
theorem,
know the compound angle, and then
right?
you get your formulas.
So you
Every
can
angle which is not an acute angle, converted into related acute and then proceed forward.
so from here we can do negative cos pi by 3
Yeah,
minus pi by 4.
apply the formula. Yeah. Cos A
And then,
cos B minus sin A sin B. Correct.
and so then you just do like the values. So
Yes,
like so whatever sine b is, you just plug that into the formula and then you just find the values
correct. And
using
beauty
the
is,
special triangle.
all those values are positive because you are in first quadrant. If I give you a combination of angles in this quadrant, sometimes you get confused. Well, now cos is negative, sine is positive, it creates confusion.
Just use your cast rule and then go from there.
Correct.
Because that'll give you what's negative, what's positive.
Yes. So we
Right.
have already reduced our big number into a number which is between 0 to pi by 2. And we are only looking for combinations which can help us get the right combination of A and B. And then apply the compound angle formula, get the exact one. Is that
Yeah,
clear to you?
yeah, that makes so much more sense. Okay, yeah, I see.
This is very important to understand. So we're
Yeah.
done this question. Okay, now let's erase question number 9. Please read that.
If sine x equals 4 over 5 and sine y equals negative 12 over 13 and 0 has to be less than x, but x has to be less than pi over 2, which is otherwise known as our 90. And 3 pi over 2 has to be less than y, but y has to be less than 2 pi. Evaluate cos x plus y. We can just do cos x plus y first, then we can go to the next one.
So we are given sine x is positive and it is in first quadrant, right? X is
Right.
between 0 to pi by 2, right? Sine y is negative, but it is in quadrant 3, right? 3 pi by
Right.
2 pi, no, fourth quadrant, right?
Fourth, because it has to be less than 2 pi, but it can still be
Right.
greater than a
So these are our cos and sine values. So clearly, we have to use this formula now. Let's do part A, which is find the value of cos x, cos y, right?
Right.
So it is cos of x, cos y. Formula is known to us. So basically, we know sine x and sine y. One of them is positive, one of them is negative. In quadrant 1, all are positive, right? So what we are going to do here is that we'll look into the triangle. So when we have this one triangle here in this quadrant, let me just draw a triangle here. The angle x, correct? So when this is 4 and this is 5, we know this is 3, correct? So we know the cos of x is 3 over 5 and positive. Is that clear to you?
Right.
The other triangle happens to be in quadrant 4, and in quadrant 4, we are given opposite side of 12, and this is 13, correct? So 13 square 169 minus 144 square root, right? So it gives you 5, correct? So that is the value for y. Is that clear to you? So make your triangles in the quadrants, and now you know the cast rule. So sine, sorry, sorry, what am I writing? Cast rule, C-A-S-T. Is it okay?
Right.
Substitute here. So cos of x is in this quadrant, all are positive, and cos value is 3 over 5. Is it okay?
Right.
Cos of y, it is also positive, 5 over 13, correct?
Oh, yeah.
Sine of x, it is positive, quadrant 1, 4 over 5, it is given to us. And sine y is also given to us, minus 12 over 13. Do you see that value? So you can now combine, and you know the common denominator is 5 times 13.
So it's 65.
And here we have 15 plus minus
plus
minus
48.
plus,
Yeah.
and 4 times 12
is 48.
8 and 4. And you can add these, right?
And then you get your exact value.
3 and 1. You're right. And multiply. Do you see that? That is how you're going to solve this question and all the parts. Is that clear to you?
Yeah.
Given the angle, you should know which quadrant you are. Make a triangle in that quadrant so that you could relate very easily whether it is positive or negative. You get the idea.
You should always make your values like in the first quadrant, and then based on what you're trying to find, the quadrant that would make that positive as well,
Correct.
unless that otherwise.
Correct.
Okay.
So do you get the idea? And still, I would like you to know this chapter has almost come to an end. We have gone to extended questions, which I'm not going to take today with you because you're not fresh with the formula. But go to the next chapter, see where is double angle and where is half angle. Go continue. Yeah. We can do all this. Don't worry. So now practice question number 4 is determine the value of sine 2 theta, cos 2 theta, tan 2 theta when cos theta is given to us. We know the formula, right? Sine 2 theta is 2 times sine theta cos theta. Plug in the values, get the answer.
Okay.
Correct? So we can
Yeah.
do this exercise, 3.9. Do you understand now?
Yeah, so it's like 2 sine of 5x cos 5x. So
Yeah.
our formula was 2 sine theta. Oh, well, sine 2 theta equals to sine theta cos theta. So then you know that your 2 has to be like your theta value has to be 2 times.
So these questions are very simple, right? 2 sine A cos B, right? 2 sine A cos A is?
2 sine A cos A.
Yeah. You remember? Sine A plus B plus
Sin-
sine A minus B, right? 2 sine 2 theta.
Sine 2 theta. Oh, yeah. Yeah.
2 sine A cos B is 2 sine 2 theta. So 2 times 5 is 10, right? So sine 10x, correct? So these are straight formula, cos 2 theta, right?
Okay, yeah. Oh, yeah, this one is just your cos 2 theta, which is your
Sine
cos.
2 theta, right? This is tan 2
Sine-
theta formula.
Oh,
These are
okay.
straight
So
formula.
I see the 2 just refers to like the
Yeah, the formula. These
your
are the
sine.
formula.
Oh, yeah, because that's just sine 2 theta. So it's 2 sine 5x cos 5x, and 5x being your theta
Theta.
value, because like 2 times 5 is 10, so you just find the sine of 10.
Correct. So what I'm trying to say is, this is the next section. If you move on to the next after this chapter, also we have done that.
Yeah,
So
double angle. There we go.
Go. So go
And these are
further.
so
Go further.
oh,
Is
no,
it? Couldn't. Okay, forget about it.
I can't
Anyway,
see.
what all your teacher has told you to do, we have done all that. I mean, no
Let's
joke.
see. Yeah. We did literally all of these, and then
All
the
this,
next
yeah,
we
all
have
this, all this section of double angle, compound angle, we've done them. Is that okay?
Yeah.
Now, before we end the class, I would like you to recall what we learned. So I'll again go to my, so you can stop sharing and I'll share my whiteboard with you once again, right?
Is this my
And
quiz?
it is an exercise which is
Okay.
more for me than for you because I'm going to write and you have to speak. So let's see who's faster. Okay. Tell me what is sine A plus B equals to? Tell me.
Okay, so it's sine A cos B plus sine B cos A.
You have to say cos A sine B. You just remember, don't correct. And if I
and then
make
you
it minus,
can do minus and the minus there.
very good. Cos A plus B equals to.
Okay,
Tell me.
so it's cos A cos B minus sine A sine B. And then you can do the plus. If you do minus A minus B, then that becomes plus.
Excellent. Tan A plus B.
I forget this one. I think it's 10. I know it's 1 minus tan at the over when you do it. 1 minus tan something.
Tan A tan B.
Okay.
So yeah, I didn't give you the formula initially. So tan A plus B is tan A plus tan B over 1 minus tan A tan. Is it okay? We can actually derive from those formulas, but we're not getting it. That will be an exercise for you. Is it okay? Sine 2A is equals to what?
Okay, so it's 2 sine A cos B?
A.
Cos.
A.
Oh, cos A.
So
Yeah.
sine 2a. There is no other angle. A is the angle, right?
Right.
Cos 2a is what?
It's just your cos squared theta plus your sine squared theta, or your cos squared A minus sine squared A plus. Oh, those are your three ones. There were three
Correct?
for them. Yeah, correct.
Let's go to double angle formulas.
Oh, I forget some of those.
Doesn't matter. We know it's square root, right?
Right, I know it's square root 1 minus cos theta over 2, and then your sine 2 theta is plus or minus square root of
This was
1.
plus.
Oh yeah, it was plus 1 cos theta. Oh yeah, because it was the opposite, because cos was plus and then sine was minus, and then your
Yes.
tan, I think that was just 1 minus over, it was 1 plus cos theta. That's what I know.
Is
Right.
that making sense to you?
Yeah, they're making, like, I'm remembering them now, like, more once we're like going over them.
So for today, just recall these formula, write the way I wrote, right? Keep on
Right,
going back and forth. There's no sequence to be followed, correct? In
correct.
between, we also picked up Pythagorean trigonometric ratios. We also
Right,
picked up the special triangles. Do you understand? No order to be followed, just randomly.
right.
Put
Just
all
keep
the
it.
exact values one after the other here and there, and
Okay.
then recall in different ways so that you could mix and match these formulas and come out with the result. That's the whole exercise. So the compound angle exercise, which is due for you, is actually this what we did, right? So we did
Right,
it like in a very general way today. We did not take up any particular value, whether it is 75 degrees, 105 degrees. How does it matter? We have to only find a combination
you
which
have
can
to
give us
find,
75 or 105.
right, you have to use your special triangles and do the combinations from there.
Perfect. So can you just revise or summarize what we learned today?
Okay, so we learned our compound angle formulas, and there's many, and we just went over them, but I still have to revise them, so I'm not going to say them right now.
Yeah.
And then we have our equivalent formulas, but it's just the same thing. You're just equating them. So like
Mm.
if you have like the compound angle formula, then you can say, because we did an example right here, but I just have to go over it. But I know it equal to minus sine x. So there's a way you can derive it using your cast rule. So you just have to look into that. And then we did our half angle theorems, which is just over 2. And we derived that using our A and our 2A, or A over 2. And that's how we did it. And we learned a lot of formulas today, so that we got through mostly half of my curriculum for this training it.
So make one full page of formula on the side. Once you do rough work, deriving them all one after the other, then put them together on one side of a page as a fair copy for yourself. Once you're done all this, then you open your book and start from question number 1 and finish it all. You get the idea. That is how you have to work with trigonometry. Okay, then.
Okay.
Good night.
Good night,
It was
Alyssa.
wonderful teaching you today. Thank you and all the best.
Bye.
Bye. You can always join my classes by writing to me on the email address given. I can be part of your success story and build strong foundation to ensure bright future.